Hello, Sonic lovers. Welcome to the channel Gone. Today, I will show you how to configure BGP route reflector in Sonic. But before doing so, I will tell you why route reflector is used. The simple answer is to avoid full mesh topology. Now, what does it mean? As we know, in this topology, this is an IBGP topology because all the routers are in same ASN, which is 65,000. Now suppose we have a route loopback 10 1.1.1/32 which is directly attached with R1. Now if I advertise this route will present in the routing table of R2. Since R1 is not attached directly with R3, so this route will not be present in the routing table of R3. Suppose, now what's the solution? Suppose if I want that this route must be present in the routing table of R3, then this router R1 should be directly attached with R3. So it will be a full mesh topology. In large networks, full mesh topology is not a good solution. So what we will do, we will use a technique which is known as BGP route reflector. As we know, SONiC is a L3 switch. So all the ports of SONiC are in layer 3 and all ports have assigned default IP addresses. So before starting of the video, all the default IP addresses have been removed. Now I will go into router R1 to configure it. Here I will check the status of IP interfaces by using command show IP interfaces. As we can see here, port 0 is not present in the table because before starting of the video, its IP address, which was default, has been removed. Now I will go into topology. Here I will assign IP address 192.168.10.1 and loopback address. Now I will use command sudo config interface IP add Ethernet 0 192.168.10.1/24. Now I will assign IP address to loopback by using command sudo config interface IP add loopback 10 1.1.1.1/32. Now I will check the status of IP interfaces by using command show IP interfaces. Here we can see the IP address has been assigned to port 0 and loopback 10. The IP address of loopback 10 is 1.1.1.1. Now I will save configurations by using command sudo config save lagby. Now here I will repeat the same steps for R2 and R3. Now I will go into router R2. I will assign IP address to port 0 and 4. Sudo config interface IP add Ethernet 0 192.168.10.2/24. Let me check again. Yeah, 10.2 and 11.2. So now I will assign 11.2 to port 4. Oops. Sudo config interface IP add Ethernet 4 and then 11.2. Now I will save configurations by using command sudo config save lagby. Now I will check the status of IP interfaces by using command show IP interfaces. Show IP interfaces. Yes, fine. Now I will go into router R3 to repeat the same steps. Sudo config interface IP add Ethernet 0 192.168.11.1/24. Now I will save configuration by using command sudo config save flag y. Now I will check the status of IP interfaces by using command show IP interfaces. So an IP address has been assigned to port 0. Yes, everything is fine. Now I will configure BGP in all the routers, because all routers have same ASN number, which is 65,000. Now I will go into router R1 to configure it. This is router R1. Vitish configuration mode, router BGP 65,000. As we can see here, it is saying BGP is already running with AS 65,100. Now I will remove this by using command no router BGP 65,100. Now I will use the same command router BGP 65,000. Now I will use command neighbor 192.168.10.2 10.2 remote AS 65,000. And now what I will do here, I will advertise this route 1.1.1/32 by using command network 1.1.1.1/32. Now I will use command and save the configuration by using command write. Now I will go into router R2 to configure it. Here Vitish configuration mode, no router BGP 65,100, router BGP 65,000, neighbor 192.168.10.1, remote AS 65,000, neighbor 192.168.11.1. Here we can see in the topology 10.1 and 11.1. Now I will use command and save the configuration by using command write. Now what I will do, I will go into router R3 and configure it. Here router R3. This is router R3. Vitish configuration mode, no router BGP 65,100, router BGP 65,000, neighbor 192.168. The IP address is 11.2. 11.2 remote AS 65,000. Now I will use command and save the configuration by using command write. Now what I will do, I will check the routing table of R2 and R3 to check whether this route is present in the routing tables of R2 and R3. Now I will go into router R2. Here I will use command show IP route. As we can see here, the route 1.1.1.1 is present in the routing table of R3 and the code is B, which is a BGP route. Now I will also use command show. Now what I will do, I will go into routing table of R3 and I will use command show IP BGP. As we can see here, no BGP prefix displayed because this route is not present in the routing table of R3 because R1 is not directly attached with R3. So what I will do, I will make R1 and R3 as route reflector client because this is a client server model. I will make R2 as server, which will act as a route reflector, and R1, R3 as route reflector client. Now, what I will do, I will go into router R2 here. I will use command configuration router BGP 65,000. Here, what I will use command neighbor 192.168.10.1 and 11.1 .10.1 route reflector client and 11.1. Now I will use command N and save the configuration by using command write. What I have done, I have made these routers R1 and R3 as route reflector client. Now I will go into router R3 and now I will use command show IP BGP. Oh yes, good. As we can see here, this route 1.1.1.1/32 is now present or in the routing table of R3 because now this router R2 is acting as a route reflector. What is it has done? Actually, when we have advertised this route 1.1.1.1/32 through R1, this route reflector has reflected this route in router R3, or we can say it has transferred this route in router R3. The interesting thing is that router R1 and R3 are not directly attached, but this route is present in router R3 by using concept BGP route reflector. So full mesh topology has been avoided. So thank you guys for watching my video. If you want more videos like this, do subscribe my channel.